Welcome to the developers meeting on Sunday, the 12th of March, right? And Ido, your stage.
Yeah, okay. This week we have some exciting stuff, I think. Let's start with you, XYZ.
Nikola.
I need to get used to your nickname.
Yeah, it's a mouthful. So last week I was working with dataset a lot. I was filtering pictures. Wait, I can share screen. Should be this one. See anything?
Coming.
Yeah.
Okay, so here on the left side is all the classes that I managed to separate. Here is the count of examples in each class. Most dominant classes are. Yeah.
Sorry to interrupt. At least me, I only see your desktop with Discord.
Oh yeah.
Oh, it didn't change. Oh.
You probably shared the window, not.
Yeah, I shared the window.
Yeah.
Now?
Coming. Yeah.
Okay.
Yeah.
So here we have some classes that I managed to separate. Zoom out a little bit. When I scroll, you can see actually the bird motion and stuff, but on some examples, it looks like a pixel blob, which is kind of tricky for our single frame classifier to discern what is actually on the picture. It works. It assumes that when it's a blob, it's a most likely bird, but is not completely sure. But now I'm working on this model that will take data series and hopefully come with a more reliable classification. So these are the examples that I have collected so far. Here is some of the plane stuff. Planes are, I think, the simplest one to classify. We don't have examples for fighter jets and helicopters, but commercial planes are there to some degree. Here are some like misaligned, not centered examples. Here are some centered. So far, all the planes are oriented in the same direction because the person who collected the data most likely lives next to an airport, and that's the data for that place.
True. Good observation, Mr. Sherlock.
So here what we have, yeah, here is I had the source files 277K of images, all in a flat hierarchy inside of one folder. So I grouped them by track ID. Here I have some examples. This stack 18, stack 19. It's just tracker stuck on one cloud and it's going for thousands of images. So I excluded these from even trying to categorize them. So then I guess we should move to code. Here is the classifier. It is built using TensorFlow and Keras. TensorFlow is compute backend for neural networks. It performs all the operations on matrices and vectors, and he applies the kernels, whatnot. And then we have Keras, which is abstraction for neural networks. So we can just say, give me a layer, and Keras will take care of instantiating the matrices for us and everything wiring up and whatnot. Here at the beginning of the file, we have some parameters for the script, how we can tune it. For example, this array directly manipulates the size of the neural network, the amount of convolutional filters, and number of convolutional filters. So if I go like here and type 1024, I would automatically expand the network, and yeah, I can also change the parameters of existing layer. This is regarding the training. This is also part of neural network. You should be grouped the same. This is to help us avoid the overfit. What this does is there is something called dropout layer, which we inject between the two layers that are learning our data set. And when we say 0.5, that means take the 50% of synapses from the previous layer and just cut it out from the equation. Don't pass them to the next layer. And this helps network to prevent overfit because it's random. We introduce random, but we try to look through the random, not to get confused by it. So this is how many epochs do we go over our training data set. One is enough for this algorithm because data set is now containing 70,000 of examples. This is optimizer parameter to influence the learning speed. If the learning speed is too high, the model can fail to converge to a minimum, and it can skip a lot. It will never find global minimum. Yeah, this is how we split our training data into testing and validation data sets. So we take original data and only 0.1 will end up in validation data set.
So wait a second. What does that mean actually? That we
Uh,
only take 10% for validation?
yes, 10% for validation to see how our model behaves, what it learned so far. This is the data that is used only to score the performance of model, and it is not used in training of the data.
Okay.
So unseen data to the model. Here we can control if this script is running in training or inference mode. So it's correctly set right now. Here we have some dataset preparation performance methods to optimize our datasets and to process them slightly. Here we have some display method to show some things in matplotlib. Again, dataset stuff. This is important because our dataset is biased and it contains only planes that are flying from bottom left to top right. Now we can apply these two operations and this a little bit and some other things to expand on dataset variety to make it more uh, optimized for
So
learning.
you multiply by 6, no, more even.
I take actually the image and it goes through this layer, and this has a random chance to apply horizontal flip. This has a random chance to apply vertical flip, and so are these. I don't think it will rotate by 0.1. It will rotate by some random number between 0 and 0.1. So we do that to make our training data richer. And these are now methods that create our model. So first, because we need to specify the input shape, what is our image size, and is it RGB, is it monochrome, what it is. So we have some entry, first convolution layer. It is pretty much copy pasted from multiple Jupyter notebooks from the internet. This is the main method that assembles majority of layers inside of a model. So it creates this input model first, then it forwards that into entry block, and then X are the hidden layers of the network, and we build on top of them in this loop. And this loop block sizes correspond to the config from the beginning of the file. So it is iterating over this array. In first iteration, it will create convolutions that have 256 filters, 512, and 728 in third one. So this is the size being passed here. These are residual connections. They are optional, but I like them. It reminds me of ResNet a lot. ResNet is existing network with residual connections. Now this is exit of the network. where we normalize data one more time, put it through activation function. Here is the dropout layer that I told you about. This is the guy that cuts off 50% of connections between output of this and input into our classifier multi-layer perceptron, or in this case just perceptron. And number of classes correspond to how many things we have to classify. It is also part of the config at the beginning of the file. Wait, I did something. Why is this white? I don't know. And here is how we train our network. We load the data, we create augmented data, so random flips, random rotations, random shifts. We run the training data set through this augmentation model. We don't run the validation data set because if it learned. Some display of data, how it looks like after the augmentations. We create the model, we print the architecture of the model, we define the callbacks. So every time when one epoch or one batch is over, our callbacks can be called, for example, to save a checkpoint of a model or to check if model stagnated with accuracy curve, and then perform early exit and not wait like 100 epochs to waste electricity or something. Here we apply optimizer onto our model. Adam is some kind of adaptive optimizer that can tune learning rate and weight decay parameters by some curve. I don't know exactly what. And here we actually train. So here is the creation of data, creation of model, compile model, the training. We register all the callbacks, and at the end we save data. And here is how we can run the model to show it random pictures and to ask him to classify one by one or in batch. So now if I go here on the left side, run it. This is because I downloaded TensorFlow from pip. I did not build it from source, so it's not optimized for all the instructions that can accelerate training. Here is information about our dataset. This is the model structure. So input layer is 64 by 64 by 3 channels. It's being rescaled to same dimensions, but we map pixel values from 0 to 255 back to into floating space from 0 to 1. So integer to floating mapping of some kind. Now we have feature extraction layers for some amount. Yeah, these are all convolutions with residual connections, which process the image to extract all the visual information like horizontal lines, vertical lines, color information, relations between everything, and to represent it in this kind of shape, 4 by 4 by 1000 floating points. And then we attach our 8 neurons to represent our 8 classes, and we train the network. And in total, it's this much parameters. So you can see it's being trained on CPU, and it's already 83% in accuracy. It didn't even end the first epoch, and it can go like 10 epochs or something like that. So in 5 minutes, we're going to have network of like 90% accuracy that works on single frame. So
Cool.
any questions regarding this algorithm, or should I talk on my next topic about time series?
I just wanted to know that from your last screen that what you showed, is this the result? What you showed here is the result of the training, right?
This is training in progress.
Training
Here
in
we can
progress.
see,
Okay.
yeah,
How many
left side.
images are now trained?
Oops. Wait. 62,000.
62,000.
Yeah,
Okay.
for training and 7K to benchmark the model and to know how it performs.
Okay. And it creates kind of 8 buckets because you have
Yes.
8 segments and it drops in these 8 segments.
Yes, at the end we have 8 neurons which have softmax activation function. So each neuron will have some value of activity at the end, but all of the activities across 8 neurons will sum up to 1, 1.0. And these are also the probabilities. So let's say the first neuron on index 0 is plane, on index 1 it's bird, and so on. And if we show it show it image of a plane, this resulting vector of 8 floating points will have floating point at index 0 the highest, so it will be 0.89, and then the remaining 7 will add up to
To 1.
1.
Cool.
So we are 87% of accuracy. Actually, I can show the when it finishes with the training. I think I set it only on yeah, it's only one epoch. I will prepare the code to
only train.
So this is on my server, new model being trained, but I already have one existing. Here are the checkpoints, exported model.
Okay.
So now I'm running it on my local laptop. This is how much time it takes for.
This is not inference. This is not
Yeah.
model in progress. Okay.
Yes, model looking at new images. So we have 111 peaks. It took 20 seconds, but it can be better with the GPU, of course.
You said this is on a CPU.
Yeah, this on CPU. Okay, so this is what I assume belongs to empty class, which has label 4 in our case.
Okay, so
And this is the
L4
probability.
is an index from 1 to 8.
Label for probability 0.97.
Okay, whatever
So
label 4 is. Label 4 is one of your 8
it's
buckets.
empty, most likely empty. Yeah,
Okay.
yeah. Label 1 is clouds. So here we have some clouds and they all belong to label 1. But for example, this one is 48% sure it's cloud. Most likely the highest next candidate would be empty with, I don't know, let's say 0.31 or something, because this is usually how they behave. Here is the bird. It's labeled 0. Here we have mislabel. It's 1 and it should be 0 also, but we have a low how it's called, probability that it belongs to class 1. Here is one more bird that is almost certain it is a bird. 6 is a plane, 6 is a plane, 6 is a plane, plane, plane. Here at the bottom we also have a lot of planes and a lot of 6s.
So there are several buckets for the same. So I see a bucket 0 and a bucket 6 for birds. Is this true?
This is no, this is a mistake of the model. He didn't recognize
Okay.
well. So bird is 0, 1 is mislabeled.
And 6?
So bird is 0. Yeah, bigger birds are being confused with planes.
Okay.
So this is 0, 0, 6, and 6. When bird is in this orientation, it looks like a plane for some reason. Here is bird, plane, even has wings. Bird and bird, also bird. Edge is 3, edge is 3, edge, edge. Yeah, this is also plane apparently.
So within your 62,000 images, this model knew the series that several pictures belong to one track is implemented in this?
No, it is each picture in its own
itself.
context.
Okay.
Mm.
Wow. That's actually good if it's just the picture by itself.
Yeah, it's looking only. So here we have example for lens flare. It's category 7.
Okay.
Also have lens flare included. Here is one more example of lens flare.
Cool.
So yeah, that's the model. And now we have okay, this is not good. Yeah, this. Some logic that will take original data that was being used in training of single frame classificator and make it compatible with time series algorithms. So we have each class containing folders instead of images, and each folder contains images for a single track.
And one folder is one track.
One folder is one track, yeah. Now I can import this into my time series, which I also downloaded from the internet. Vision transformer. I'm still learning this architecture, so I can't talk much about it, but it has also the parameters at the beginning, dataset preparation methods, then architecture assembly, building of the model. There is a good amount of lines here we tweaked and researched. But in theory, this example could work on our data. Right now, it is working with organ set 3D, which is collection of fMRI and CT scans, like three-dimensional images, volumes of tissue. And they can be also fed to the model in sequential order and pretty much behave like time series models, even though they are designed to operate on volumes.
So how do you prepare the data for this model? Like, do you have like a certain file name besides directories?
This is now in this example there is already this data set
Oh,
in some form
yeah.
of NumPy export or something like that. So I'm
Okay.
exported images in form of, I don't know, NumPy arrays, but I need to change this entire function. Instead of loading from remote URL, you should load from directory and process however we need it to be processed.
Yeah.
And
So
we already
the
have
ordering
some
of the files here are important, right?
yeah. Here it is important. So this is not done. Files
Okay.
are
Yeah.
cooked.
That's file names. Yeah.
Oh, that's a wrong folder. But we can see the comparison. So we have this data is for CNN classifier, and it has edge, which is full of images.
Yeah.
From multiple tracks. So 3E, 3F,
Yeah.
and so on.
Yeah.
Here is the time series dataset. and now we have tracks, and each track has its own. I guess this is ordinal number of tracks, and frame count. Right now it is in, I don't know what order, but when I load it in code, I will sort it using this thing.
Yeah.
And then feed it to the model. And plus I need to optimize it, because this model, if I understand correctly so far, here is the shape. So 28 by 28 is the X and Y of the picture, and 28 is the depth, or the in temporal dimension, CT slides. So this is the one thing that needs to be considered. It should be 64, 64, whatever I decide for this one, whatever I can decide by data. And here is the patch size that is also, I think, related with time-related stuff, sequence
So
stuff.
just for my understanding, do you can you go back to the input time, the input data, a bit up? No, on the code. Yeah, the input shape.
Input shape. Yeah.
So it's X, Y, and the other one is what, time dimension?
Yeah. So how they made these scans in fMRI machine, or what it was?
So here
it goes slide by slide.
So if we have, let's say, 20 frames per second, here will be like 20. If we want to classify
if
by
we want
second.
1 second.
Yeah. Okay.
Yes, exactly.
Yeah.
And this one at the end is channels. So this data set, it's monochromatic images representing tissue densities or whatever, and we are going to have 3 channels. Or if we decide to use the pre-Bayer filter data, then it would also fit here in a monochromatic fashion.
Nikola, we assuming these pictures is from OCam or from a PTF?
It can work with both things, because this is the point of neural networks. You create one architecture and then you just swap the data, and it will learn any data. So if you go to PTZ, I don't know, it will be 128 by 128, and I don't know, 5. But this is right now for all SkyCam, for crops, 64 by 64 crops.
But 360 view change something or not?
We shouldn't, because I'm training model from start, so it will learn everything, even if it's fisheye and distortions and everything.
Okay.
Is there a way to display the features the neural network found?
Yeah, in theory we can halt the model. Yeah, I think we could. People do that. I can't remember how it's called. Convolutional maps or something like that.
Okay.
Yeah, in theory. But usually people don't do it. They just test on validation set and see the score. Because most often, the deeper the network is, the less meaning it has to human. You just look at it and okay, it's, I guess, something. But only the first layer of a network would be meaningful, because first, where is my browser? Because first layer. Maybe something like this. We would see and it is also too much things to visualize. So in example of single frame analysis, we had like 256 different feature extractors. So that would be a lot of data to inspect, but we could, I think. And it would look something like this. So which is pretty much vertical and horizontal feature line detection filters. pretty much like this. We would see, and it's not meaningful for us.
I have a question or two, if that's okay. I'd like to find out about the 64 by 64 size. So it's vital that the input image that we ask to be classified is 64 by 64 in size.
Yes.
Is that okay? So I guess then my other questions would be, what happens if, this is not necessarily a question to you, it's more in general, I think, is what happens if we find something that's bigger than that? Do we resize to 64 by 64, or do we just not try and classify?
Bigger than.
Yeah, resize.
So
So I was thinking about that during the training time.
May I interrupt here? So the images that you saw are, let's say, the flight
Sure.
path towards an airport. The planes that are flying overhead. Can you show some planes? Just some examples. Are planes of 727, 747, all sizes, and the distance is.
No.
The shortest distance is 500 meters to 1,000 meters. Vertical.
No, sorry guys, I can't show.
What I want to say is these images have a representation of a plane between 10 to 20 pixels. So in order to fill up 64 pixels, the object must be either very big or very close.
Yeah, so
it's a mothership.
So I'm not
on your roof.
Yeah, so it's more just like it's more just in general, like what do we do? So so basically, I'd like to maybe work with Fabio and just kind of put some more info into the background subtractor so that it only so that essentially the bounding box I get from the background subtractor is in. Is like a scale of 64 by 64. Because I don't know, like for example, if we get a bounding box that's 128 by 128, regardless of what it is do we submit it for classification, or do we rescale it down to 64 by 64 and then submit it for classification, or we just ignore it, or
approach.
we just rescale
64 by 64 and feed it to model.
Okay.
And also regarding the labeling data, if the picture is not square, don't even put it in files.
So it has to be 64. Like the image that we submit for classification has to be 64 by 64. It can't really be.
It has to be the size of the input. There
So
are some techniques that.
Mike, I will submit, the best bounding box you can get from the tracker, okay? And then we will have transformation to match it to the classification.
It can happen even on separate node, like.
Yeah.
I don't know.
No, we'll do it like Ross way, right?
Yeah, no, I know. I just kind of want to get this stuff. I want to try and get this working.
Yeah.
As soon as I can, and then we can obviously improve it. But the main thing for me is just when I run some tests and I don't get any hits, then I just need to also understand that it's maybe because the image I'm submitting is bigger than 64, but that sort of thing. So
most likely model would fail. It would say something like shape mismatch. I was expecting such and such, but such and such.
Okay. All right. Okay. No, that's fine. That's yeah. That answers my question. I'm going to try. I'm sorry about last week, man. I spent a week branching up the wrong tree, sort of thing, barking up the wrong tree with the stuff I was looking at, and I'll so this week I'm gonna look at the embedding TensorFlow into a ROS node. There's already an example of that, so I'll grab that, see if I can get it to work,
Yeah.
and kind of just let you know as soon as I have anything to report back, really, and then we can, once I can get that pipeline working, we can then improve it. The main thing is just trying to get something up and running.
Yeah, sounds like a plan.
Cool.
Richard,
Mike?
can you?
Excuse me.
I was. If you're not talking, if you can mute your microphone because it's inputting a lot of noise to the.
Is it
Mine.
mine?
Yeah, it seems like,
Oh yeah.
but much better. Yeah. Oh,
Oof.
much better.
Oh, thank God.
I didn't even realize.
Really? It's
Ah.
your microphone?
Yeah, it is. It's a lot of noise.
Better now?
Yeah.
But yeah, much better now. And now I can hear everything. Nice. Yeah.
Cool.
Are you going to show anything more, Nikola, or else I would like
I don't
to
have
share.
anything
Is
much
this
more.
better now,
Yeah, you can share.
Haido?
I'm
No,
sorry?
it's not.
Is this
No,
better now? Still?
no, lots
Yeah.
of noise. Yeah.
Jesus.
Okay, guys, I'm gonna show you here thing that Richard asked last. After I thought this was last meeting. So it's the live stream from the camera. You guys can choose. Just tell me.
Yes.
Oh. I made. Let me just made this thing here. So this is a live stream from the camera here outside. Just increase the exposure. And we can select any part of the image to see it on full size here. For instance, or I can just hit here. So for me to adjust the focus. For instance, I will just play with the focus here on my for you to see. Oh, I play with sorry. Then I can just adjust the focus of the image till it's good.
Mhm.
So that's what I did for getting the live stream. So know what you think about it. We can change gain, we can change the exposure of the camera. We can right now it is 16 bits, we can change to 8 bits. And I can put more parameters for us to play here. Just for getting the image, the live stream from the camera. So what do you think, Richard? Do you think that's enough for like doing the?
That looks good.
And this is from my 178 camera. I can put the 183 if you guys want. I just to plug it on the USB, but I can show you guys. Let me just this. Just put the 183 here. Since the 183 is connected to my scope, so it's very narrow right now. So connect here. Yeah, let me just put it over here a little bit. This is coming from the 183 right now. I have the full resolution here. If I just click in here, I have this thing here upscale to 1 by 1. It's coming from the 183.
Nice.
Fantastic.
And we get almost 8
This is a
frames
lot
per
of
second.
detail.
If I put to 8 bits right now, let me show you.
Yeah.
Look at here. It's an 8 bit. Oh, it's
How many FPS?
Almost 40. You can see 48. Oh wow.
yeah, but yeah, I'm capturing the amount of time I have for the full frame.
Yeah.
It might be return the same frame twice, maybe, I don't know, because it just returned the frame. It's
Yeah.
we can get as much as we want, so it's working fine.
Nice.
8 bit. Put 16 bit, it goes to 8 FPS, but this is amazing. So like
Yeah.
here, we can just put it here and adjust the focus.
And this is running on Orange Pi.
Orange Pi, yes.
This is from our camera.
Yeah, that's
Yeah.
for our camera. Yeah, that's
okay.
that's what A3 that's connected here. I can adjust the gain here, so let's reduce the gain a little bit.
And do you get
But
16
they're having fun. They're dancing.
You get in 16 or
there.
8-bit images?
Right now it's 8 bit, but I can put 16 here. It's just
I was thinking the last week when I thought about our speed problem and the bits. Do we really need 16-bit with the all-sky-cam with the fisheye to capture an event? I don't think so.
Yeah, I think we are going to rely much more on the changes in
Yes,
pictures across frame to frame.
no, totally agree. Totally agree with that.
and that's why I want you guys to choose, and then we won't proceed the 16-bit thing in the all-sky and the fisheye cam anymore. So let's do a vote about it. If we keep on pursuing 16-bit for the moment or not, we can add it later on if hardware will change, let's say in 1 or 2 years. But I think let's do a vote to skip the 16-bit part for the all-sky cam.
I think that's a good idea because if you got to 8 bits here, look how fast it is, man. It's just incredible.
Yeah, it's insanely fast. And especially at low light performance.
Yeah.
Because we need to identify human-made aircraft by its signalization. And with higher FPS, we can capture the beacon sequence much more than with 12-bit 6 FPS.
My argument would be that that if you go to the 8-bit and then come back 2 years later and add 16-bit, we can't go backwards with all that data. So it would be better for us to start with 16-bit and deal with the shortcomings of the hardware, so that, because we're talking days, weeks when people will start being able to support 16-bit. I know this because we're already starting to build them, and there are the other manufacturers that are building 16-bit cameras. So the processing power will come along very quickly.
That's not about processing power. Right now, the problem is the amount of data that we need to get from the camera. Processing power.
No, it's the frame. You want to get more frames.
Yeah. If you want to get more frames, it's hard to get in 16 bits. That's
so
I have for 5 frames.
Yeah, so I have a different mindset. I think about 18-bit and 16-bit as variables that I can change in runtime. Okay. Now the amount of data that we can transfer, like my hope, is that we can start with 8-bit, and if we notice something, we can increase it to 16-bit, reduce the size of the frame we're capturing from the camera, and maintain the high frame rate, but only focus on the box that we see, right?
That was exactly what I had in mind.
Yeah. So you know, the full frame as we capture can be also a combination of both 8-bit and 16-bit, when 16-bit is where we have interest, right? Yeah.
I totally agree. And you can change it on the fly. We can change all the parameters of the camera on the fly.
No, I'm thinking about, like, if we're building our own firmware, technically we can have an image that has both.
Yeah.
Okay.
Yeah,
Give
'cause we're
you
doing
18-bit, give you 18-bit, and give you 16-bit where you need it,
right.
right?
Yeah.
It's another overlay or whatever. We can figure it out. But
yeah,
that's a very ambitious and very long-term solution.
yeah, but
Right?
anyway, the problem will be always be the amount of
Yeah.
bandwidth for the USB
Yeah.
and not the image itself.
Yeah. Now, in practice, we all know that we need higher frame rate. The easiest way to achieve it now is moving back to 8-bit, right? So I'll vote for that for now.
Me too.
And now let me see if it's working here. I'll try to show you the ROS nodes working with the camera.
Nice.
I have to increase the exposure because it's not dynamic right now. So take some time to see. The couple is still there. So. Takes a little bit of time to start the camera node here.
So this is supposed to capture the data and publish on topic.
Yeah, this is doing that right now. It's the same couple here, if you can see it here, and the tracker is working, but it's getting nothing because nothing is really moving a lot here. If I start and put on the other camera, then you might see a lot of things moving. Just wanted to show you that it's working with the 183.
Nice.
It's publishing, and it's everything that's on ROS here right now. So if I had something moving here, let's see if I had something moving, or I don't have anything moving on the screen. It's working. I'm gonna just end the camera. So just a second. Show it working. This is not dynamic, so I'm just gonna stop it here, or else will not see nothing. Just a proof of concept, so. Just trying to get the camera working with the ROS nodes and everything's working. It's going to show now.
Nice.
The real, I was going to do a more better demonstration, like running some nodes on my PC and some nodes on the Orange Pi, but I couldn't make that work now. So I'll make that for the next week. So that's okay. That's showing the camera here. Let me just move the thing back to.
Nice.
Put it. since it's running a lot of tracks right now, things get a lot slower. You'll pick up anytime soon. A lot of errors here. I don't know. I have to figure out.
Yeah.
Okay. That's it. The problem right now is just about performance because everything is running on the Pi, even the streaming. So you see that it's
Yeah. Nice.
that's what I wanted to show you guys.
Cool.
Fabio, you wrote that you updated to the latest Ubuntu version for Orange Pi, and
Yes.
the USB driver is working now. Can you elaborate shortly?
That's what I show you on the last on that application that was showing the output from the camera. So it's up to full speed right now. So it's working full speed here. You just increase it.
Okay. So Ido, does that mean if it's now updated in Ubuntu that NixOS is coming soon?
No.
Any update there?
No.
If
No
you-
update there.
If you see it here, the speed, we are running here in 16 bits on a 6 megapixel camera here, and it's working perfect, man. It's like full speed. And if I put to 8 bits here, for instance, it will just... Okay. The FPS here just goes crazy because it's full time. We can do anything here, and so this everything's on the Orange Pi and running and getting in the everything from the USB. So everything's fine right now. So it's amazing.
Cool.
Nice. Glad to see they fixed the kernel.
Yeah. I think they did. They in the past week they released like 3 different versions of the Ubuntu. They went from the 1.1.2 to 1.1.5 like in 1 week. So
Yeah.
So they are working hard on that. And before we had a lot of visual issues with these things like moving things here, and right now everything's working fine. So they are doing a good job.
Yeah.
Yeah, that's it. And so right now we have like full USB, and that's fine. And then that's great because it doesn't slow us down, and we can test things in more real time. So.
Nice. Yeah, that's good. Really, really good. Awesome.
Okay, guys. Let me just share it.
Any more updates from anyone? Okay, Christian, I guess back to you.
Hey, before we get off this, after we discuss all the hardware, I have something I need to share with everybody about something that's going on, and it can be recorded as well. But we all need to be aware of this to look for something. But I'll wait till you guys talk.
Okay. So I did some work this week. I'm playing with a real-time kernel on Linux, just to see how it behaves. But I didn't do much work on that, more than that. Just had a busy week. So, Richard, back to you.
You were talking about a NixOS kernel right now, did you?
Yeah, and it's Linux kernel. Yeah. In NixOS, it's just one line configuration change. But I want to try testing this kernel a bit, see the performance compared to a regular one. So I'll get the code from Fabio, and I'll start playing with it. Yeah, actually, no, Fabio, I'll probably wait when you're going to go C++, right? You're going to write it in C++, right? When you're fully... Yeah, okay, so I'll wait for that. Yeah, I'll wait for that. Okay.
So now that David
Yeah.
is here, hi David. Hey David, you hear us? Oh yeah.
Hey.
Hey,
Hi.
good to see
Hi,
you
bro.
again.
Yeah.
Ido, by the
Yeah.
way, I'm still you producing a lot of noise?
Yes.
Oh,
Yeah.
damn, okay.
Yes.
So my proposal would now be that David shares his findings from the last couple of weeks.
Sounds good. David, you're on.
Sure. Just wondering, is it your computer, Richard? Are you near a fan or something?
I'm on the laptop here and on a stupid little headset, so
Right.
this is producing a lot of noise. Sorry for that.
No problem. Yeah, I suppose I can report back what I've been looking at this week. I've been looking at the background subtraction algorithm vibe, just doing some analysis on how that works and the different kind of backgrounds, challenging backgrounds, all the way from like clear blue sky days to full cloud cover and everything in between, and the effects that has on things. So I wrote a little report. It was more for my benefit. I can share that with you. I'll post it up on the Discord. It's quite long, but yeah, it's hopefully a starting point. It just helped me understand the algorithm a bit better and what those parameters are doing, and how we could potentially tune them to try and get the best out of the algorithm and try and reduce false positives and things like that, before it goes, improve things for things that come downstream with blob detection and the stuff that Yannick and Nikola.
Sorry to interrupt. I have to step out. Something came up and I have to pick someone up. I want to thank you guys for the good work you've done the last week. And yeah, it looks very forthcoming. So see you next week. Bye.
See you.
Bye.
Bye.
Have a good one.
Yeah, I can quickly. I'll just give you a very quick overview of what I've done. I'll share my screen. Hopefully you can see this.
Yeah, we can see. We can see.
Yeah, so this is a report, and I can put it up. It's
Sorry, David, you shared your window, Discord window, not the Discord.
Okay. Okay. Try again. Thanks, Richard. Is that any better?
Yeah.
Yeah. So this is a report. I mean, I was looking at, as I say, different kind of cloud levels and seeing what we could do with the background subtraction based on the cloud levels. I mean, so yeah, first thing I looked at was these 7 videos here, going all the way from blue sky to full cloud cover and different percentages of cloud cover in between. I just looked at the false positive rates. And in stable conditions where we've got blue sky or we've got complete cloud cover, we've got a low percentage of false positives, as you'd probably expect. If you've got something like this in between with a light source and broken cloud, you get a high number of false positives. So I then went on to look at the different parameters of vibe and doing like an exhaustive sweep just to see how we could, try and get some information about how we could work with these parameters to reduce the number of false positives. So I've written that up, but just to kind of give you the highlights. In challenging conditions, it's harder to get good performance out of Vibe. You get a lot of false positives, but threshold parameter can really help things. So obviously, if you've got a lot of false positives, you can raise the threshold up, and that will give you a better performance. There's other parameters as well as BG samples, required BG samples, and learning rate. The threshold is kind of the main one that has an impact on things, but BG samples is another one we could potentially work with. But I went through all these, did some analysis. You can read through that if you want. I played with some post-processing as well, just to see. In the original Vibe paper, it recommended applying a medium blur in post-processing. So I played with that, and that helps with precision quite a lot, but it reduces the recall. So the effect of that is you don't get as much of the moving object potentially in the foreground mask. And it has a bit of an impact on FPS as well if you're applying a medium blur. So got some data on that. If you want to kind of skip to the highlights, I wrote some recommendations based on this analysis of what I've been doing. It's on the last page. But one of my recommendations, and it's just an idea, is to see if we could use some sort of little optimization algorithm if the conditions change significantly.
Yeah.
So if we've got like a perfect blue sky day, we're starting off, we can run on really low threshold, and we shouldn't really have too many problems with false positives and things like that. But if the conditions change quite a lot, then we can adapt the threshold and adapt the other parameters to try and get the best performance out of Vibe. But I was proposing that we could use a little optimization algorithm for determining what parameters would be good. So this week I was playing with Nlocked. It's like a nonlinear optimization library, which is pretty cool. But I built a fitness function that runs Vibe. It runs some simulated moving objects on the frame, and then records things like F-score and different metrics. And then it tries to determine what the best parameters are for the current conditions. So if I give you an example here, just bear with me.
Oh.
So if I run this, so we've got some challenging conditions. The cloud is moving across the frame. We've got some issues with recall on these moving objects, so you can see they kind of fade in and fade out. We don't have many false positives, which is good, but the recall is pretty poor here. You can see the readout there, but so what I was going to do is run that through this optimizer. If I can run this, so it runs a global nonlinear optimization algorithm, and basically the fitness, the closer it is to 1, the better the parameters for the background subtraction for those conditions. So it takes a little while, but it should be there in a minute. So it runs that global optimizer first, tries to find a good parameter set, and then it runs this little local optimizer to try and improve things even more. And it's doing this on about 5 seconds worth of video data. And at the end of this, it spits out what it thinks are the best parameters for the current conditions. So I've got 35, 17, 2, and 6. If I just plug these values in here. So 35, 17, 2, 6, and then run this again. We got, hopefully you can see much better recall. You look at the metrics at the top left, you've got high precision, high recall. So I was just proposing that we maybe consider doing something like this optimizer when the conditions change by some amount, you know.
Or even run it every 15 minutes and update the parameters.
Yeah.
That would also be an option, but doing it fully continuous would be even better.
Yeah, agreed. That is
So maybe, sorry, the cloud cover estimator, we could have it running every 5, 10, 15 minutes or something, and then if cloud coverage change by X amount, then we run the optimizer over, say, 100 frames or something like that. It's just an idea.
We can have it run like in the background every let's say 5 minutes, 10 minutes for like 100, 200 frames, and then shut it down and feed the parameters to the tracker.
Sounds good. Yeah.
So like an observer on the tracker, right?
Hyperparameter tuner.
Yes.
Cool. Yeah.
Nice.
Would it make sense, Idle, to turn this into ROS nodes so you can control it on the fly?
Well, it will control it. Yeah, that's the idea. So this is like part of the AI automation, right, of Sky 360. So it acts as an observer on the system, and it's sending commands to change parameters.
So actually, the code that David produced shall be converted into a ROS node, right?
Yes.
The question is, who does this? David, are you doing this, or shall we look for help in doing this?
I can have a go at it. I mean, I wrote this in Python. The library I'm using is nlopt. It's a nonlinear optimization library. It's open source. It's got C++ implementation as well. So, I mean, the actual kind of monitoring is not that difficult, really. It's just, I mean, it's something I can.
I mean, I'm happy to help you plug it in as well. So yeah, that's no worries on my side.
Mike, it's important that rather than this node changing parameters directly on the tracker, that it's actually publish a topic for recommendation that the tracker listen and then update itself internally.
Yeah. So currently the way currently the way I process or deal with those sorts of dynamic sort of changes is that I have a configuration node, and the configuration node stores all the configuration.
Yes.
And other nodes subscribe to configuration changes that they are interested in.
Okay.
So if, like, for example, if we need to change certain parameters, a node will tell the configuration node to change 3 parameters once the configuration node accepts that change and makes that change, it then publishes to all nodes to say these configuration changes have been made,
Okay.
and then it's dependent if it's dependent on the node. If they subscribe to that configuration,
Yeah.
they then get the update, and then they have to reload their node to then take into consideration the configuration change.
Yeah. Okay. Well, so what I'm saying, let's be more specific here, because the recommendation here will be about multiple parameters together. Okay. And
Yeah,
I
so
rather,
it's just a batch. It'll just, so I would just, that's for me, that is just a batch. I mean, we can,
I'll tell you what I'm after. Okay.
okay.
I want to see the recommendation changes over time, and rather to look at all the parameters that are changing to actually have a higher order event on that.
So okay, so there's nothing stopping us from publishing that onto a node as well.
Yeah.
And let me get it working by using the configuration system, and then we can always elaborate on that. And if we want to publish it in different ways for recording purposes or whatnot, then we can.
Yeah, it's more about like when I need to look at why the tracker changed, all these parameters change, and let's say it's like 4 or 5. It's actually nicer to see that there was a recommendation, right?
Yeah, so we could have a monitor node or some sort of observer node that listens to all configuration and records when a configuration change is made.
So I will say the opposite. First, do a recommendation, and then from the recommendation, update the configuration. Because you will be able to stop a recommend. So the way to get to a full automated system is by accepting and denying automation recommendations, right? Speak about like AI. Okay. Now, if you tap into directly to configuration, you just change it immediately. There is no way for me to control it on the batch. I'm not speaking about one specific. But start, however, we can change it in later on. I'm just trying to position it. I'm sorry.
Say tracker is. I have example. Let's say tracker is tracking something really important, which is not belonging to any class. We don't know what it is, and we don't want to reapply config mid-time when we are tracking something really interesting. Is this your idea?
That's
so
a fair
we
point.
listen
Yeah,
to the recommendations and decide then.
Yeah, the idea is to give the AI should give the recommendation for automation, and that will start changes like increasing to 16-bit the camera, reducing some stuff that are taking computational power, so we can focus on grabbing the data. Right, there is a lot of stuff you can do. Right, and the idea is from one recommendation now you have a lot of actions you can take, rather than having the action first and figure out what was the recommendation. Okay?
Yeah, makes sense. Makes sense for a final station to be that dynamic and capable to adjust to any situation that it is in.
So I would I'd probably suggest like some sort of controller node then that basically coordinates this sort of stuff. So basically it will, so the whole configuration system still stands, but the controller node gets notified that there's a better optimized set of parameters that can be applied. It's up to you whether you want to, like, it's the gatekeeper. It's up to you as to whether you want to allow those to be applied. Yeah, sort of thing.
I'm looking at it also from separation of concerns, right? Like this recommendation has no idea about the tracker, okay? And it should not interfere with the parameters of the tracker. That's for the tracker responsibility. So it can only give recommendation, and then the tracker can choose, or the gatekeeper, whatever, to actually apply it. But the tracker needs to have a command, apply these changes, this configuration. Okay?
So okay, I get what you guys are saying. You know, it's just how that's implemented. So let me, I think, like, first things first, let me get David's auto tuning implemented as a node so that it can auto tune, and then we can discuss how we decide whether to implement the parameter change, like what the best sort of, you know, if it's a controller node or how, whatever that is, whatever that looks like, we can then we can then do that. Would that
sounds good.
Is that okay? Okay.
Yeah, sounds good. Cool. This is amazing. We're getting there slowly. It's good.
Right, getting there. Brings me to the point we shall talk about the user interface as soon as possible.
Yes. Are we going to have a talk right now, or you want to discuss it after this call?
Yeah, let's do it afterwards.
Okay. Sounds good.
So
yeah, y'all saw.
Excuse me.
You saw that Rebecca bailed, right? She had to go to work.
Hold on with that, Tommy. I stopped recording for now. So I think we do not have any more updates for now, so I can stop recording, right?
Yeah.
Okay.